Hello and welcome to this video where I'm going to be going over ideas on maximums and minimums of quadratic equations and how we can find them in different methods. Okay, the first one I'm going to be going over about is a typical one. Imagine that we have a function that is y equals ax squared plus bx plus c. I'm going to assume that a is positive just for the sake of making a sketch, but if a were negative, everything would be exactly the same, with the only difference that the parabola would be concave down instead of concave up. So in our most generic form, we could have that my parabola was something like this. That's a kind of nasty drawing, especially for this part, but we could make it work somehow. The idea is that this parabola should be symmetric with respect to a certain line of symmetry. It matches the x. I'm going to make it so that it doesn't match the x's. I'm going to be drawing it, for example, something around here. Okay, now that's better. So that the axis is not in the axis of symmetry is not in the axis. So this is x and this is y. We have a line of symmetry that runs through here. The idea is that if the parabola is well drawn, these two branches of my parabola should be symmetric. And this point that we have here, where this line of symmetry intersects the parabola, is called the vertex. So the question is, how is it that I'm going to find these coordinates for the vertex? In general, in mathematics, these coordinates are given the letters h and k. So in general, we will have this. And in particular, if we have the value for h, then the value for k is just changing here all of the expressions on the periods of x. We're going to put an h. So our goal is going to be finding how we can find the value for h, because then the value for k is going to be like quite evident. So scenario number one is we have roots. This is alpha and this is beta. If we have roots as the parabola must be symmetric, then my value for h, this will be like our first method, my value for h is going to be the value for alpha plus the value for beta over 2. Expressed in other terms, the value for h is going to be the average of my two roots. It's like our first and easiest method if we know the roots. If our process were like, okay, find the roots of this function, then great. The next step, finding the vertex, will be quite straightforward. And scenario number two is, okay, what happens if we don't have roots? If we don't have roots, we can think of it. I'm going to be like deriving a formula here, so bear with me. We can think of it as if alpha was, and using the quadratic equation, the quadratic general formula, we could be using that is negative b plus b squared minus 4ac, everything over 2a, and then beta could be negative b minus b squared minus 4ac, everything over 2a. This is, as I was telling you, the general formula. And the expression alpha plus beta is the same as negative b plus the square root of b squared minus 4ac over 2a plus negative b minus b squared minus 4ac, everything over 2a. We can add these two expressions because they have the same denominator. So we can say that a plus b is negative b plus this radical minus b minus this radical. This b with this b will become negative 2b. And then this radical with this radical will cancel each other out. So we're just left with negative b, negative 2b over 2a. The 2's will cancel out, and this is negative b over a. So in general, we can say that as h was this value over 2, we can also say that h is going to be equal to negative e over 2 times a, because we have this 2 that appears here. So we're dividing this over 2, we get this 2 there. This is another formula that if some of you know how to differentiate, you will find the resemblance there. I'm not going to talk about differentiation now because that is something I'm going to be leaving for further topics. But if you know how to differentiate, that's another option. I want to focus on our third method. Okay, these are two methods that probably you should know about, and they are quite straightforward. In the first case, if you have the roots. In the second case, it's just plugging in the values. Now, I'm going to focus on this third method because this third method is usually asked in the mathematics A levels. So as it is usually asked, it's important that you know it. And this is method number 3, completing the square. How do we complete the square? Let's look at an example. Okay, I'm going to be doing an example here. This is going to be y equal to, I'm going to write negative 4x squared. It's going to be plus 16x minus 7. So what is it that I'm going to be doing here? I'm going to first complete the square. I'm going to write it here. I'm going to complete the square. And then I'm going to use the complete the square to find the expression for the vertex. So how is my complete the square going to look like? I want to write my equation in the following form. A times hx minus h squared plus k. And yes, I'm using h and k on purpose. You will see why. So how do we complete the square? Well, there are different methods around this. The one that I think that is easier for you is expanding everything. So how do we expand x minus h squared? This is going to be x squared minus 2hx plus h squared, and this is plus k. And then we take the distributive rule here. This is going to be ax squared minus 2hx plus ah squared plus k. So what do we want now? We want that this that we found here is found with the terms of a, h, and k to be equal to this. So we do this term by term. The term that has x squared has to be equal to the term that has x squared. It's quite straightforward, I believe, that the value for a must be negative 4. Now, the term with linear x here is negative 2hx. This should have an a, sorry, here I forgot that this is, as we're taking the derivative, this would be negative 2ah. This should be equal to 16. So how does this work? This is negative 2ahx is equal to 16x. But we know the value for a because we know that a is negative 4. So here we're getting that negative 2 times negative 4, this is going to be 8. H is equal to 16. I can cancel the x's out, and h is equal to 2. And then finally, I need to work with the constant terms. The constant terms must be equal to negative 7. So again, I have the value for a. A is negative 4. I now have the value for h. H is 2. And that square plus k has to give me negative 7. As that has to give me negative 7, it's going to be 4. 4 times negative 4, this is going to be negative 16. Negative 16 plus k is negative 7, and hence k is 9. So I have completed the square. I'm going to write this down now in the expression with the completed the square. I'm going to erase this. In case this method was a bit fast to you, I have a specific section on my quadratics, solving quadratic equation video on this, focused on this, so you can check that one out as well. I'm going to go on right in the expression and why we can use this. So we said that this example that I provided here can be written as y is equal to negative 4 times x minus 2 squared plus 9. This is what we call the hk expression of the function. This is very, very useful. Why is that? Well, think about this. This is a parabola that is not like this one. It doesn't have this shape because it's concave down. It's like this one. So if I were to draw it, it would look something like this. Okay, so it's going to have a maximum over here. This is the point that I'm looking for. The thing is, everything that I have here, this term here, as I square it, is going to be positive. And then I'm going to multiply something positive times negative. So everything here is going to be negative. So I have this 9 here, and I'm going to keep on adding negative things. So as I keep on adding negative things, the result that I'm getting is always going to be less than 9. So the highest value that this can take is 9. If I look at this here in my y-axis, the highest value that this can take is 9, because for anything that is positive here, I'm going to multiply times a negative. So this is going to be negative, going to be 9 plus a negative. 9 plus a negative is always going to be less than 9. So the highest that this function can be is 9. And the question is, when is this equal to 9? This is equal to 9 when all of this part is 0. And as this is not 0, the only solution is that this part is 0. And if this part is 0, that means that my x has to be 2. So my vertex is the point 2, 9. This is like an explanation on the formula that I'm going to be showing you now. In general, we have what we call the vertex form. If an equation is given like this, y is equal to a times h minus x minus h squared plus k, then we know that the vertex has coordinates h, k, and this always happens. So in general, you will find this is a very typical exercise where you are given that if you're given a quadratic formula, you have to first complete the square and then find the vertex. Well, it's this same process. You first turn it into something of the form hk, and then you take the value for h that is here. In this case, my value was 2. And then the value for k that is here, in this case, is 9. Watch out for the symbols. Watch out for the negative here. This is the opposite of what you see here. You see that this is negative 2. Well, your value for x is going to be 2. Here you have a 9, then it's a 9. Okay? As usual, if you feel that I went too fast, you want to emphasize something, you can leave your questions in the comment section, and you can check my webpage for more exercises. And I hope to see you on our next video. As usual, thank you for watching.